truss analysis. So if we want to analysis, that means we can calculate what is the force induced in the members due to the external loading. Second one is what is the deflections will be formed due to the applications of the load. So these two are comes under the analysis of the truss. So if we want to analyze the any type of truss, first we should know either it is statically determinate or indeterminate. Like throw-foot cantilever, first we know the basics. Then after know that is statically determinate or indeterminate. Then we can develop one compactability equation. From that compactability equation, we can calculate rope reaction, support reaction, bending moments, and we can draw the bending moment. So likewise, in case of trusses, first we should categorize the given truss is statically determinate or indeterminate. That is the first step. Second one is see if we can apply any 10 kilonewtons at a joint, what is the induced forces developed in the members due to the 10 kilonewtons. Second one is the what is the deflections formed due to the 10 kilonewtons. So this is the analysis. So now you can see the diagram. So this is the combination of the straight and inclined members. So by observing the front view, we can see that that is the triangular shape. So in case of trusses, the triangle shape is best one. So why we can call it is the best, which will satisfy the statically determinacy. That means external indeterminacy, internal indeterminacy. When we can see the truss, we should know the what is its external indeterminacy, internal indeterminacy. For the given diagram, this external indeterminacy completely related to the support reaction. So how we can calculate external indeterminacy for the given truss? First we can draw the free body diagram, then we can know the support reactions, then there is one equation for the external indeterminacy. So that is for the number of unknowns minus equilibrium. External completely depends upon the support reactions. I repeatedly tell external support reaction. Don't confuse. In case of beams, we can know the statically indeterminacy, kinematic indeterminacy. But in case of trusses, we can calculate external indeterminacy, internal indeterminacy. External means support reaction. Internal means that's related to the, for the given truss, there are how many number of joints are available, and next how many members are available. So based on that equation, M equal to 2J minus R. So based on that equation, the given truss is statically determinate or indeterminate, we can decide it. So this is the another type of truss. Next one in this diagram, all of you can clearly observe. So this is inclined members, straight members connected at the joint. All of you remember, this is pin jointed trusses. So why we can induce the pin joint trusses, which will allow the small amount or negligible amount of deflections or expansion of the member, which will transfer to the abutments or supports from the abutments, that will be transferred to the soil. So whatever may be the applied load, which will transfer to the members, from that members it will transfer to the joints. So these are the pin jointed trusses. So these are the some of images of trusses. So now in the case of analysis of trusses, we can analyze the trusses having statically determinate. So from the beginning, when we can call it as statically determinate means the complete unknown forces in the beam or frame can be analyzed by the equilibrium equations. So that's why in case of trusses, we don't need or we don't develop any compatibility equation for this statically determinant. If it is indeterminate, definitely we will develop another equation. Like in case of simply supported beam, I don't develop any deflection equation, compactability equation. If it is throughput cantilever, then definitely we need the one extra equation. Likewise, in case of trusses, if it is statically determinate, so that's mean the definition itself very clear. The unknown forces means support reactions at the two ends, and next one is the forces in the members. These two, that means support reaction unknowns, forces in the members can be alone calculated by the equilibrium equation sigma fx, sigma fi, sigma ma. By using three equations, we can calculate support reactions and internal forces of the member. So as per the introduction, as per this very simple definition, truss, which is connected inclined line straight members, connected at the pin jointed trusses. The best shape of this one is the triangular. There is a classification: plane, space. Plane having the 2D problems XY, space having the three-dimensional object. So in this case, UG level, we will solve only 2D problems. So this is the truss frame beam. So beam which will meant for the transferring the transverse loads. That means in case of beams, we will apply at any point of the length of the beam. So but in case of trusses, we will apply the load at the only joints. But in case of frames, we will apply the load at any length of the beam. So finally, in case of beam and frame, analysis consists of shear force bending moment. But in case of frames, analysis consists of tension compression. So this is plain truss definitions. Now if you see the diagram, all of you clearly observe that. So there is a external loading, blue color, which will act only at the joint. So all of you clearly observe, there is a blue color load which will act at the joints. Because of the joints, in between the triangular members, there will be a tension and compression, which will transfer to the end points through the pin jointed trusses. Pin jointed trusses. So when the water is flowing in the canal or river, if we don't put any obstruction, it will force straight line. మనకి ఎక్కడన్నా వాటర్ స్ట్రైట్ లైన్ లో వెళ్తున్నప్పుడు మనం అబ్స్ట్రక్షన్ ఏది లేకపోతే ఫ్లో లో అలా వెళ్ళిపోతుందండి. అలా మనం ఏదైనా అబ్స్ట్రాక్ట్ పెడితే ఇట్ విల్ బి స్టోర్డ్ ఆన్ ది వాటర్. సో లైక్ వైజ్ ఇక్కడ పిన్ జాయింటెడ్ ట్రస్సెస్ కాకుండా మనం ఫిక్స్డ్ జాయింట్ ప్రొవైడ్ చేస్తే at that location the joint will be break. So that means fixed joint cannot allow the rotations or the deflections. Our joint work break అయిపోతుంది. To avoid that, we will provide the pin jointed trusses. So this is the load transfer in case of the trusses. So now I come to the our main topic, how we can classify. So when we can see the truss, what is it? External stability, internal stability. So the stability of the stress classified into two types. First one is external. So I can write external support reactions. Internal, that completely depends upon the number of members and the joint. So external stability, call it as statical stability or external indeterminacy, that's related to the support condition. Whereas in case of internal stability, geometric stability, so that is configuration of the joint. So finally, the stability of truss is categorized to two types: external, within the brackets, support reactions; internal, within the brackets. In the internal means there is a only availability of the members and joints. So within the bracket, internally, relation between the members and the joint. So when we can see any type of truss, first I can know the what is it external indeterminacy, what is its internal indeterminacy. So now we can see the there is a lot of theoretical explanation. I don't want to explain the all of the terms. At the third point, or sorry, fourth point, the unknowns are the number forces and the reaction components Therefore, if the structure is statically determinate, we can write the relation M equal to 2 minus R. If we want to calculate internal indeterminacy, M equal to 2 minus R, or otherwise this can be modified. So my voice is audible to all of you? Hello?
Yes, sir.
Right. So there is a, in the case of stability, there is a lot of theory. I can completely so ignore the theory. So I can write one equation, M is equal to 2 minus R. Or this equation we can modify, M plus R equal to 2Z, where M equal to number of members, R equal to number of components. Number of components means what are the support reactions available for the given problem. మనకి ఇచ్చిన problem లో depending upon the support conditions batti we have the support reactions, that is called the number of components. J equal to the number of joints. So this is the equation we can use for the either the truss is statically determinate or indeterminate. So in case of our syllabus, we can determine, sorry, statically determinate stresses. So all of you remember M equal to 2Z minus R, or otherwise M plus R equal to 2Z. M means number of the members, R equal to the reaction components, J equal to the number of joints. So if there is a relation between M equal to 2Z minus R, 2Z less than M plus R, so then there are more unknowns than the equilibrium equation. The structure is statically indeterminate. If we can see the any truss, then we can calculate M equal to 2Z minus, 2Z less than M plus R. Then we can say that structure equal to the statically indeterminate, or otherwise M is, 2Z equal to M plus R, that is determinate. If it is not equal to, then directly we can say indeterminate. And you can see the last one, 2Z equal to M plus R, the structure is statically determinate and the unknowns can be obtained from 2Z equations. At the last one, 2Z greater than M plus R, there are not enough unknowns. The structure mechanism, the structure mechanism is always unstable. So then we can see 2Z equal to M plus R, that is stable. 2Z less than indeterminate. 2Z greater than M plus 1, that is unstable. That is the classification. So now we can see the clear description. Total number of unknowns M plus R. So if M plus R equal to 2Z, then the stress is statically determinate. If it is less than 2Z, that is indeterminate. If it is greater than 2Z, that is unstable. So based on M plus R equal to 2Z equation, we can classify the truss. The stress is statically determinate or indeterminate. M plus R equal to 2Z. So for this class, for these trusses, all the trusses are statically determinate. That means all the trusses given in the deflections which will satisfy the M plus R equal to 2Z. Unfortunately, if they cannot give the like the problem, then you will convert it that into statically determinate. Then you can calculate deflection of the forces in the member. మనకి సిలబస్ లో డిటర్మినెంట్ ఏ ఉందమ్మా. అలా కాకుండా మీరు ఎగ్జామ్ లో ఈక్వేషన్ సాటిస్ఫై అవ్వకపోతే అక్కడ ఏదో ఒక మెంబర్ గాని సపోర్ట్ రియాక్షన్ రిమూవ్ చేసి యూ కెన్ సాల్వ్. So these are the equations. Now if we want to calculate static indeterminacy, ds equal to dsc, degree of static external, degree of static internal indeterminacy. So how we can calculate external indeterminacy? dsc equal to r minus equilibrium equations, where r equal to total number of reactions, so which are available at the support condition. So when you can see the truss, first we can calculate M plus R equal to 2Z, M plus R equal to 2Z. So that is statically determinate. Then what is its indeterminacy? Like when you say the proput cantilever, so that is statically indeterminate. What is its degree of indeterminacy? Then we can follow the number of unknowns minus equilibrium equations. For the trusses, for external indeterminacy, number of unknowns minus equilibrium equations. So that is R minus equilibrium equations. And internal indeterminacy equal to M minus 2J minus 3. M minus 2J minus 3. Finally, the static indeterminacy for the any type of truss is equal to the degree of external static indeterminacy plus degree of internal static indeterminacy. Degree of static indeterminacy equal to the number of unknowns which are available at the support reactions minus equilibrium equations. When come to the internal indeterminacy, dSi equal to m minus 2j minus 3. At the bottom side, that is perfect redundant. So now, if you want to calculate total static indeterminacy like propelled cantilever degree of indeterminacy, here we have the two types of the degree of indeterminacy. One is external indeterminacy, one is internal indeterminacy. External indeterminacy equal to the number of unknowns minus equilibrium equations plus internal indeterminacy m minus 2j minus 3. So now all of you take a small problem. I request all the members. So there is one triangular truss. This is plain truss. One end is simply supported, one end is pinned connection. So all of you take the problem. HC, that is roller support, HB, that is pinned support. So can anyone say what is it? External indeterminacy first. So this is the given. So when we can see the truss, we will categorize what is it, external indeterminacy, internal indeterminacy. So anyone, what is its external indeterminacy or internal indeterminacy? Out of 40 members, there is one person at least. What is its external indeterminacy? Or otherwise, what is its internal indeterminacy? Hello? Hello?
Sir.
Ma unnara lera?
Sir.
Hello?
Yes, sir.
For the given diagram, I'm asking repeatedly, but no person is respond. So for the given diagram, at least anyone can respond. Sir, we don't know. Sir, we know. For the given diagram, what is its static external indeterminacy, internal indeterminacy?
Zero, no, sir.
So okay. Anybody? So how we can calculate external indeterminacy? That depends upon the equilibrium, support reaction. If you take B, that is periodic condition. So there are two unknowns. If you take C, that is roller support, there is one reaction. That finally external indeterminacy equal to R minus equilibrium equations. R means reaction component. 3 minus 3 equal to 0. Then what about the internal indeterminacy? How many members are there in the given diagram? Members.
Three, sir.
Three.
How many members? 3. So that
Three,
is
sir.
A, B, B, C, C, A. How many joints are there?
Three, sir.
Three, sir.
3.
Three, sir.
Now if we apply the M equal to 2J minus 3, that equal to, we can get the 0. So when we can see the any type of truss, first we can identify the what is the support reactions. And next one is what are the number of joints, number of members. First all of you take the problem. Now you can complete these. The given one, I can draw the free body diagram. So at B, there are two support reactions. All of you take the rough problem. So we can calculate determinacy of the trusses. So calculation of static indeterminacy. So that is external plus internal. First we can calculate external static indeterminacy, DSE. At point B, that is pinned condition. There are two conditions. Here we will consider the sigma fx. But in case of beams, we will eliminate that sigma effects. So at B, 2 unknowns, at C, 1 unknown. So ds equal to R minus equilibrium equations. So that is R equal to 2 plus 1, 3. So finally, external indeterminacy equal to the R minus 3 equilibrium equations. So that is 3 minus 3. So don't confuse external indeterminacy. What are the support reactions available at that conditions? Minus equilibrium equations. Now if you take the internal indeterminacy, dSi equal to m minus 2j minus 3, where m equal to number of members 3, j equal to number of joints 3. Now if we can apply m equal to, sorry, dSi equal to m minus 2j minus r, so that is 6 minus 3. Finally we can get this 0. The final degree of static indeterminacy equal to degree of external plus degree of internal, 0 plus 0. So this is the perfect example of the trusses. That means when there is a classroom of 60 members, 20 benches. For each bench, 3 members are sitting. So then there is, then the completely, all the students will be occupied by all the benches. There is no extra benches availability, deficiency of the availability. So that's why in case of trusses, triangular shape is the best one. So why? Because it has the indeterminacy, external as well as the internal. So in this case, what that what the diagram indicates. So that means this has the indeterminacy equal to 0. That means we don't need the any extra equation. The same is similar to the cantilever. If you take the cantilever, there are 3 support reactions at the fixed end. While you write static indeterminacy, number of unknowns minus equilibrium equations, 3 minus 3 equal to 0. Similarly, in case of simple triangular truss, if we can apply the external indeterminacy, number of unknowns minus equilibrium equation. So from now onwards, if we want to calculate external, internal, what that degree of indeterminacy indicates. So the degree of indeterminacy indicates how much additional equations we can require. If you take the proput cantilever, there is a degree of indeterminacy equal to 1. What is that one? One compactability equation we can generate. Here also depending upon the, so మీకు ఎవరికైనా డౌట్ రావచ్చు సార్ డిగ్రీ ఆఫ్ ఇండిటర్మినెన్సీ ఎందుకు కనుక్కుంటాం ఎడిషనల్ మ్యాథమెటికల్ ఈక్వేషన్ ని డెవలప్ చేయడానికి క్యాలిక్యులేట్ చేస్తాం. Now if you take the second problem, all of you take the second problem. Can anyone say what is it? External indeterminacy, internal indeterminacy. Just take rough diagram only. Anyone? External. But 26, Narama. Roll number 26.
Yes, sir.
So what is the type of, what is its external indeterminacy? External.
0, sir.
0, good. How?
Number of here one side we have roller support.
Right, good.
One reaction, sir. And
Okay.
another side we have in support. We have a
There
two
is 2
unknown.
reactions. Finally, right, 0. So number
Total
35, what is its internal indeterminacy? Number 35. Roll number 35. Okay, number 8. So we have the only limited 30 minutes time. So can anyone say what is its internal indeterminacy? One of your friends said, sir, this is external indeterminacy equal to 0. She can give the explanation good. So can anyone say, can anyone explain what is its internal indeterminacy?
Zero,
Okay.
sir.
Zero, sir.
Entama?
Zero,
0, 4. So
zero,
now
Zero.
you
zero,
can see
sir.
the right. Good, good. From the diagram, you can take that. So external equal to the like previous one. So as one of your friends said, at rollers so pinned condition 2, at the roller support 1, 3 minus 3 equal to 0. In this diagram, number of members 1, 2, 3, 4, 5. Number of joints 4. Now we can get the equation D equal to 0. So this is also statistically determined. For the analysis of the given diagram is, sorry, for the analysis of the given truss, we required only equilibrium equations. We don't require any additional equation. In case of any interviews, anyone can ask, what is the benefit or use of the calculating degree of indeterminacy? Depending upon the degree of indeterminacy, we can calculate how many number of additional compatibility equations we can require. So now you take this one, third diagram. Just all if we take rough diagram. Just to go through your fundamental basics. First we can calculate what is its type of support reaction, number of members, number of joints. Then you can apply the simple multiplication and addition. What about its external indeterminacy?
One, sir.
One, sir.
One, good. What about its internal indeterminacy? So this is the given two triangles connected at a point. Can anyone say what is its internal indeterminacy? Just you can blindly count the number of members, number of joints, reaction components. Always remember small r equal to the reaction components. Right? So as one of your friends said, the degree of external indeterminacy equal to the 1. So why? Because this is having two pinned conditions at the support conditions. That means at the two ends, two unknowns are available for minus 3 equilibrium equations. Small r equal to the reaction components and internal indeterminacy equal to the, here we have the 10 members. If there is any wrong in the number of members, please inform me. J equal to the number of joints. Now we can apply m minus 2j minus r. So 10 minus 2 into 7 minus 4. So what about the degree of internal indeterminacy? Is 0. External indeterminacy equal to the 1. But finally degree of static indeterminacy equal to the 1. So for this problem, we required one additional equation to analyze the given truss. Previous two trusses are the statically determinate. So this is the statically indeterminate. So to calculate these forces, we required the one additional equation. Now if you take this one, what is its external, internal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, So now I will take the, as usual, basics. Its external is 2 having the pinned connections, 4 minus 3, 1. Here the number of members are 14, number of joints are 8. So we have the 2. Here this is having indeterminacy of degree 2. Second degree indeterminacy. Previous one is 1 degree indeterminacy. First two problems are the statically determinant. We don't require the any additional equations. All of you completed this problem?
Yes, sir.
Yes,
Hello?
sir.
Right. So
Yes,
we can
sir.
see the, okay. Now we can see the 1 or 2 problems. You can observe the diagram. Ever mali practice chedam okasari diagram chudandi. At the support, that is one is pinned connection, one is the roller support. So that's externally equal to external indeterminacy equal to the 0, 3 minus 3. Internal indeterminacy equal to the m plus r. So this is statically determinate. So likewise, so all of you can observe this diagram. These are the support conditions or support conditions which will be provided at the end of the members. If you see that member is not directly fixed to the support, at the support to the member there is a one connection, that is pinned connection, so which will allow the small amount of deflections. So now if you from the next time if you travel along the any truss bridges, you will observe the at the end conditions. So definitely you clearly see that there is a pinner roller support. In the second diagram, that is the roller. Now these are the some images of the trusses which will having the connected to the at the bottom pinned connections. Now how we can analyze the statically determinant plane truss. So what is the step-by-step procedure? What are the assumptions? The first assumption is the all the members are connected frictionless hinges. The axis of all the members lie in single plane called the plane truss. The forces acting applied at the joints only. So if you want, what are the assumptions? The first one is all the members connected at the pin jointed trusses. Second one is loads act at the joints only. Third one is the pins are connected frictionless pins only. So these are the some assumptions. So these are the some statically determinant stresses. These are also some other examples for the determinant stresses. Sorry, statically determinant. So likewise, we will calculate the more number of the trusses. So for this class, all of you practice some other 5 or 6 problems, which will you know the for the given trust, that is statically determinant or indeterminate. After knowing the either it is determinant or indeterminate, then we can solve the method of the joints. Method of the joints and method of the sections. Two methods are available to calculate deflections as well as the forces in the member. So any doubts? Hello?
No, sir.
No, sir.
So don't worry, Amma. We are at the beginning. Competitive exams lo gate lo prepare అయ్యేవాళ్ళు, you should concentrate on the statically indeterminates, external indeterminates. So in coming to the theoretical, so that is there is no problem. Sigma fx, sigma fy. That is very easy but laborious. It will take more time. So tomorrow class we will take how we can analyze the statically determinate stress, that is method of the joints. Thank you.